So this is example 5.5.2. This is a projectiles question from Edexcel M2 June 2011. So the question says a particle is projected from a point O with speed u at an angle of elevation alpha above the horizontal and moves freely under gravity. When the particle has moved a horizontal distance x, its height above O is y. And we need to show that y equals x tan alpha minus gx squared over 2u squared cos squared alpha. So as with most questions, most projectiles questions, it's always useful to have a quick sketch of what's happening, just so we have all the right information. So we've got a particle being projected from a point O. I'm, for the purpose of this question, assuming that point O is on the ground. It won't affect any of the working out that we do afterwards if it's not on the ground. The working out, the method will still work. So it's projected with a speed of u at an angle of elevation alpha. And we're told that when the particles move to horizontal distance x, its height above O is y. So if we pick a general point on the path of this particle, it doesn't matter where. So I'm going to assume it's about there. So once it's moved to horizontal distance x, its height above O is y. And we're being asked to form an equation linking those two things together. So as with any projectiles question, we want to look at horizontal motion and vertical motion separately. So if we consider everything we know about the horizontal motion and then everything we know about the vertical motion. So horizontally, we know that after some general time t seconds, this particle has moved a horizontal distance x. And its initial velocity, we know, horizontally anyway, its initial velocity is u cos alpha. And this happens at some general time t. So with that, because there is no acceleration horizontally, we can form an equation that says s equals ut. This is just part of the suvat s equals ut plus a half at squared. So x equals ut cos alpha. And if we consider a similar thing for vertical motion, so we have vertical displacement is y, because that's how high it is above O. And initial velocity vertically is u sine alpha. The time is still some general time t. But vertically, we also know, we're told in the question that this particle moves freely under gravity. So we know that vertically, its acceleration is negative g. Negative because it's in the opposite direction to initial velocity. So with that, we can form the suvat s equals ut plus a half at squared, which gets us y equals ut sine alpha minus g over 2 t squared. Now, if we compare that to the equation we're being asked to prove, there are no t's in the equation that we're being asked to prove. So the way that we go about the rest of this question then is that we have got to eliminate t's. So if we treat this like simultaneous equations, so t equals x over u cos alpha, and then we substitute it into y equals. So if I just write that over here, y equals u times x over u cos alpha sine alpha minus g over 2 x over u cos alpha all squared, then we can simplify that down to y equals, the u's cancel. So y equals x sine alpha over cos alpha minus g x squared over 2u squared cos squared alpha. Sine alpha over cos alpha we can simplify down to tan. So y equals x tan alpha minus gx squared over 2u squared cos squared alpha. And then if we go back to the question just to check that that is the same equation, and it is. So that's part A. Part B, talks about a girl throws a ball from a point A at the top of the cliff, at the top of a cliff. The point A is 8 meters above a horizontal beach. The ball is projected with a speed of 7 meters per second at an angle of elevation of 45 degrees. And then by modeling the ball as a particle moving freely under gravity, find the horizontal distance of the ball from A when the ball is 1 meter above the beach. So again, if we consider drawing ourselves a bit of a sketch, just so it makes it more clear exactly what's happening. So if we draw a girl throws a ball from a point A at the top of a cliff. The point A is 8 meters above a horizontal beach. So we have a cliff, 8 meters above a horizontal beach, and a ball is thrown off that with a speed of 7 at an angle of elevation of 45 degrees. And we are asked to find the horizontal distance of the ball when it's 1 meter above the beach. So find the horizontal distance. So find this when the ball is 1 meter above the beach. So obviously with the projectiles question, we can consider horizontal motion and vertical motion separately. If we know the vertical distance that this ball has traveled, we can use that to find the time it takes to do that, to travel that distance, and then we can use time to find horizontal distance. But if we notice, in part A, we did all of that already. So we found two equations, one for horizontal motion, one for vertical motion, and then we combine them together. So a quicker way of doing this question would just be to use the equation that we showed in part A. So we know the vertical distance that this ball has traveled. So remember y, the question told us that y in the equation that we proved was its height above O. Height above O, O being the point from where the ball was thrown. So if we think about that, y is the displacement of the ball. It's the height above where the ball was thrown. So it's the height above the point A. So we know that the height above the point A for this ball when it's 1 meter above the beach is -7. And we know that it was, U was 45. And we know that, sorry, that's wrong. We know that alpha is 45 and U is +7. So we can use that. We can substitute all of those into the equation that we have for y. So -7 equals x tan 45 minus gx squared over 2 times 7 squared times cos squared 45 degrees. If we simplify all of that down, that becomes -7 equals x minus 0.2x squared. And then if we rearrange that and use our calculators to solve, we get x equals 8.9 meters to two significant figures. Remember, if you use g equals 9.8 in any of your working out, you need to be rounding your final answers to two significant figures. Now, part C for this question says, a boy is standing on the beach at the point B vertically below A. So a boy is standing on the beach at the point B vertically below A, and he starts to run. So B is over here on the beach, and he starts to run in a straight line with a speed of v meters per second, leaving B 0.4 seconds after the ball is thrown, and he catches the ball when it's 1 meter above the beach. So he catches the ball and when he stood at this point here. So we know that the boy is traveling with a speed of v. So that means he's not accelerating, he's traveling with a constant speed. So in order to be able to find what that speed is, we first need to know both the distance that he travels and the time that it takes him to travel that distance. We already know the distance because that's what we worked out in part B. So he moves the same horizontal distance x that the ball does, but it's the time that he takes that we need to find. So we know that he leaves B 0.4 seconds after the ball is thrown. That means if we can find the time it takes the ball to go from point A to when it's 1 meter above the ground, then we can use that to work out how long it takes the boy to travel from the point B to when the ball is 1 meter above the ground. So we're going to do that. We're going to find how long it takes the ball to travel from when it's thrown to when it's 1 meter above the ground. The quickest way of doing that, obviously, will be to just consider horizontal motion, because then we don't have to think about acceleration. So if we think about horizontal motion, we know that the horizontal distance that he travels, that the ball travels even, is 8.9 meters. Obviously, at this stage, you don't want to use 8.9 in your working out. You want to be using the exact value that you found. So you want that stored in your calculator. We know the initial velocity was 7 cos 45, and t is what we're looking for. So for the ball, 8.9 equals, well, let's just go with t equals 8.9 divided by 7 cos 45, which means t equals 1.802 seconds. So then the boy, we know, leaves 0.4 seconds after that, which means that the time for the boy is 1.802 minus 0.4 seconds, which is 1.402 seconds. And then we can consider, to find what the velocity, the initial velocity for the boy is, we consider speed, distance, time again. So we know that the horizontal distance that he travels is 8.9. We know that it takes him 1.402 seconds to do it. So we're looking for U. So 8.9 divided by 1.402 equals, well, V, which is the speed of the boy, which is 6.4 meters per second, to two significant figures. We're giving our answers to two significant figures because we've used 8.1, as acceleration due to gravity.